So in the last few videos, we've talked about different concepts associated with electric charge. And we're going to talk a little bit about the relationships between these different concepts in this video. So we first introduced sort of the most fundamental of them, which is this idea of the electric field, which is what all charges produce. We talked a little bit about electric force, which is the interaction between charged particles. We talked a little bit about electric potential, which is the scalar field that sort of characterizes the landscape of the energy. And then we talked about the electric potential energy, which is the energy associated with pairs of charged particles. We talked a little bit about how some of these are related to each other, but in this video we're going to talk about how they're all sort of interrelated. So we'll start with the most foundational of them, which is the electric field. And the first thing we'll do is we'll relate that to the electric potential, which we've already done in a previous video. So if we want to get the potential from the electric field, what we need to do is take the negative integral of the electric field along some path that tells us about the electric potential difference between 2 points. If we want to get the electric field from the electric potential, what we do is we take the negative gradient, or the negative derivative, 3D derivative, if you will, of this electric potential. Now, the way that the electric field is related to the electric force is relatively straightforward. We bring in another charge, and we see how that charge interacts with the electric field. So to calculate or determine the force that's on that test charge, what we do is we take the product of that test charge and the external electric field due to all of the other charges. If we want to go the other way around, we want to measure the force that's on a test charge and determine what the electric field is at that point, then what we do is we take that measured electric force and we divide it by the value of the test charge that we use. That will give us the electric field at that location. Now, just in one of the last videos, what we did was we figured out how this electric force is related to the electric potential energy, right? And so what we do for that is very similar to the process for finding the electric potential. We take minus the integral of that electric force along some path. That will tell us about the change in the electric potential energy associated with that change in location. If we want to go the other way and we want to figure out what the electric force is as a result of the electric potential energy, what we do is take the negative gradient of that electric potential energy. Now you can see these are very similar operations. One involves force and one involves field, but they actually sort of relate to each other very cleanly. In a similar way, we can actually relate the electric potential and the electric potential energy in a very similar way to dealing with the field and the force. So to get the electric potential energy associated with a given electric potential, what we'll do is we'll multiply whatever the test charge is by that electric potential. And if we were to go out and measure the electric potential energy with a given test charge, we could recover what the electric potential is by dividing whatever that measured energy is by the test charge that we used. So this sort of square here gives you a sense of how all of these different electric quantities are interrelated, how you can get them from each other. Now what's interesting about them is all of the ones that are on this side are all scalar quantities, right? The electric potential energy and the electric potential are scalar quantities. And to get them from the vector quantities, we have to take integrals, basically line integrals. Everyone on this side is a vector quantity. And to get them from our scalar quantities, we have to take gradients, right? The other thing that's interesting is if we look at it vertically, these lower ones describe interactions. These are pairs of particles. So they're how pairs of particles interact, whereas the electric field and the electric potential have to do with sort of sole particles or combinations of source particles. So this is actually all having to do with sources. So this diagram actually helps you sort of organize how to connect different electrical concepts, but it also gives you a sense of how vector quantities in electrostatics can be connected to scalar ones and vice versa, and how the sources are related to the interactions.